Hi guys, so you just got done graphing inequalities using a calculator. Now I want to talk about how we can solve these inequalities using algebra. So I have the number line up here from that last one that we did together. And do you guys, excuse me, so do you notice how this number line is split into 3 different regions? Like this one here, and this is a region, and this is a region. So it's split into 3 different regions by a set of 2 points. It's split up by these 2 points. So those 2 points, in this case, in this one, it's -5 and -3. Those are called critical values. Those are the ones that are separating our number line into 3 different regions. And those are going to be critical, funny, those are going to be critical in solving these using algebra. So let's get into examples so I can show you how to do it. We're going to solve this by algebra. This is number 7. X squared minus 10x plus 18 is less than or equal to -3. First thing I want to do is I want to write this as an equation. So, and then I'm going to solve the equation for x. And I'm doing that so I can find my critical values. Solving this for x, I'm going to bring my 3 over here. Oh, there's going to be a plus sign in there. And now I'm going to factor this. Oh, sorry. What do things multiply to get 21 and add up to get -10? It'd be -3 and -7. I'm going to set both of these equal to 0 and solve for x. So x is equal to 7 and 3. This means that our critical values will be at 7 and 3, or 3 and 7, I should have wrote that as. Okay. Since our critical values are 3 and 7, those are going to be the things that split up our number line. So I'm going to put this on a number line. And 3 and 7 are going to split our number line into the 3 regions. We have everything that's less than 3, everything between 3 and 7, and everything greater than 7. And now I don't know where I'm going to graph on here. I don't know if I'm going to graph in between here or on the outside. So I don't know if it's going to be an and statement or an or statement. This is kind of the part that sucks. Is that we have to test an x value from each of these 3 regions to determine which type of statement and where we're going to graph on our number line. So step 3, fun. So let's start with this region over here on this side of 3, and I'm just going to go with that first number to the left of 3, which would be 2. So I'm going to go x equals 2. And then you got to plug that into your original equation, which was x squared minus 10x plus 18 is less than or equal to -3. So I'm going to put a 2 into there. And when I do that, I will have 2 squared minus 10 times 2 plus 18 is less than or equal to -3. And then I will have, so 4 minus 20 plus 18 is less than or equal to -3. 4 minus 2, -16 plus 18, 2. So 2, a positive 2 is less than or equal to -3. Is this true? No, because 2 is greater than -3. So this is not going to work. And then, so we need to test something from this region. I'm going to go with 4. I'm going to go 1 to the right of 3 there. I'm going to go with x equals 4. And I'm going to plug my 4 into here. So we'll have 4 squared minus 10 times 4 plus 18 is less than or equal to -3. 4 squared, 16 minus 40 plus 18 is less than or equal to -3. 16 minus 40 plus 18, will give us a negative 6 is less than or equal to negative 3. Is this one true? Yes, negative 6 is less than negative 3. So this one is a yes. Let's try our last region right here. Let's go x equals 8. So I'm going to have 8 squared minus 10 times 8 plus 18 is less than or equal to negative 3. 64 minus 80 plus 18 less than or equal to negative 3. Again, 2. 2 is less than or equal to negative 3. Is this true? We already said it wasn't in the first one, so no. Do you guys understand where I'm getting these numbers from? Where I got my 4 from, where I got my 8 from, where I got my 2 from? That can be any number in that region. For this one right here, where I said x equals 2, I could have put any of these numbers to infinity. I could have put a negative 25. It still wouldn't have worked, but you can pick any number that is less than 3. For the second one, where I did x equals 4, you can do any number from 3.00001 to 6.99999, whatever. You can do any number between 3 and 7 as long as it doesn't equal 3 and 7. It has to be between them. And then for this last one where I did x equals 8, that can be any number to the right of 7. It can be any number bigger than 7. You can pick any number that you want to. I just picked the simple ones, and which you will probably do anyway, but I want you to know where I'm getting those from. Okay, so this is the one that worked. Negative 6 is less than negative 3, and we had plugged a 4 in there. We were testing this region of our number line. We were testing that region, so that is the one that works. That is the one I'm going to want to shade in now. When I tested a value here, and when I tested a value here, they did not work, so we are going to leave them unshaded. And now, I want to write my inequality statement for this. And so x is going to be greater than 3. If you see that, x is going to be greater than 3. And x is going to be less than 7. Oops. So now, it's an and statement, and we can write that with the x in the middle and have both of our numbers. So x is less than 7, but also x is going to be greater than 3. So here is our solution for that one.